Before we start the video, let me give you a brief introduction about myself. I'm Chandresh Mahajan, who is founder and chief educator at Exergic, which is India's most trusted and comprehensive institute for online gate preparation. I got an All India rank 37 from Gate Mechanical Engineering, and I am an ex Indian Oil officer, having 6+ years of teaching experience as of now. To know more about me or Exergic, you can contact us on these details. Also, you can download Exergic Gate Preparation app from Google Play Store. The link is available in the description of video.
Just like we covered vector addition, sum of vectors, where we found out their resultant, their vector resultant, right? In a similar way, you can multiply two vectors as well. Now, I'm sure you will get confused that how two vectors will be multiplied. Because if I talk about scalar multiplication, for example, if I want to multiply 4 with 3, what does it mean? It means that I have 4 units of something, okay, and I am repeating it 3 times or repeating it 2 times to get total 3 times, right? So basically it is telling total number of activities performed. Just giving a random example, right? It is telling you something which you can feel, which you can intuitively feel that okay, 4 multiplied by 3 means maybe there are 4 chairs in every row and there are 3 rows, so total 12 chairs are there, right? But if I talk about vector product, I have a vector, okay, this is a vector that I have. Let me draw it here. This is a vector that I have and this is another vector that I have, and now I want to multiply them. So what exactly it is telling? What exactly am I talking about? Am I talking about multiplying their magnitudes? But what does it tell me? Does it tell me anything which I can use? For example, 4 multiplied by 3 in the example that I gave was telling you something useful, that okay, total number of chairs in all the rows, right? It is something which you can use further for any purpose. But if I just multiply their magnitudes, I don't see what is the use of that, right? Similarly, am I talking about multiplying anything, maybe the angle that they are making from any reference? What exactly am I talking about? Or what exactly can you do when you are multiplying two vectors? I'm sure this question will hit you once we talk about the product, the multiplication of two vectors, right? And that should come to your mind. So let's first understand that, and let me clear this up that you are not going to have direct questions from dot product and cross product or simply the product of two vectors in mechanics, but it is something which I'm sure you would have seen in engineering mathematics. You would have used this at some places or the other, here and there it will be used. So as such, it's not going to get asked to you, but it is surely one of the very basic concepts, one of the fundamentals of engineering, or you can say of mathematics, or obviously of the mechanics. So there are many students who are who are very good, but they don't exactly know what actually we meant by the product of two vectors, right? So this is the time to clear your fundamentals. Now, I was telling you that what exactly the product means, right? So before you carry out the discussion on product multiplication, it should be clear in your mind that what is my objective, what exactly I want to have when I am multiplying something between the two vectors, right? Just like in 4 multiplied by 3, we were trying to count the total number of chairs. There was an objective that got fulfilled by multiplication. That operation, that function was called as multiplication. So what exactly can we do here? What exactly can we multiply here to have something which is meaningful? So you must be having some purpose before carrying out or before trying to figure out what multiplication is. So on that basis, we have two categories of product of two vectors. Both of them have different purposes. The product here is not that direct and simple as it was in scalar product, right? Both of them are different because they both serve different purposes. Both of them are totally different in what they are trying to achieve. One product is called as dot product and other is called as cross product. So there are two categories of it as I have written here. Dot product is also called as scalar product and cross product is also called as vector product. Now I'm sure you are seeing so many new terms all of a sudden. Dot product, cross product, vector product, scalar product, right? Don't get overwhelmed, don't get confused. It is very simple, very basic. Suppose you have two vectors as I have shown here. Listen to me very carefully, alright? If you have two vectors as I have shown here and you want to know their product along the direction of any given vector. Again I am saying, if you have two vectors like this and you want to know the product of their magnitude, along the direction of either of these vectors, then that comes under dot product. What I want to say, now let me tell that in in the terms of some variables. Suppose this is some vector, let's say v1, and this is some vector v2, or let's name it p and q only. Vector p and vector q, alright. If I want to multiply their magnitude, now how is the magnitude of a vector represented? If p is a vector, then it is represented by p and an arrow above it. The magnitude of this vector, magnitude of vector p, is denoted by p vector and mod around it, which tells the magnitude of the vector. Or in casual language, we directly write it as p. It's not correct. We do this that we directly write p means it's the magnitude of it, magnitude of the vector, but the actual representation is this one. Now, for some time I will be sticking to the actual representation, then automatically I will start writing p and q when talking about the magnitude. So, coming to the dot product. If I want to multiply the magnitude of the two, means of the p and q, but in the direction of either of the vectors, either in the direction of p or in the direction of q, then that product is called as dot product. Now, how do I multiply? Suppose in the direction of p, I want to multiply their magnitudes. So, its magnitude is q. How will I multiply its magnitude in this direction? For that, you need to have a component of this vector. If this is angle theta, theta is the angle between p and q. So, this vector is cos theta. Q cos theta, right? Now, P you have and Q cos theta you are having in this direction. What will be the magnitude of this vector? This one. What will be the magnitude of P? The magnitude of P. This product is called as dot product of two vectors P and Q. I have just defined the vector right now. I have not even told you till now that what is the purpose of it. Why we want to do this? If you have two vectors, for example, one is force, other is displacement. You know that whenever we are calculating work, we always want the displacement in the direction of force, right? And if you don't know that, then you will be knowing this by the end of mechanics, because we will talk about that. Because whatever work is being done by a force is measured by the displacement in the direction of force only, not in any other direction. Okay, if there is displacement in some other direction, we take a component of that in the direction of force, and then we multiply force and that displacement to get the work. So there it is useful. Force is a vector. In W is equal to F and D, force is a vector. Displacement is also a vector, but you wanted the displacement in the direction of force. So there you are multiplying two vectors, right? But you are not randomly multiplying their magnitude. That doesn't mean anything. You are multiplying the magnitude of one in the direction of the other. That is something meaningful that we can see when we are calculating work. In a similar way, there are many other such parameters other than work also, because only a limited part of vector we are studying, right? There are other such parameters also which are not in our syllabus, which are not in engineering, but those are such product where you need the component of one vector in the direction of other, and that gives you some quantity. So that is an example of product of a vector. Obviously two vectors are being multiplied, but in this fashion, you are taking one's component in the other direction and then you are multiplying them. That product is called as dot product. And why it is called as dot product? Because when you are representing it, then it is represented by P dot Q. This is how it is represented. That is why it is called as dot product, because you can actually see that there is a dot between them, right? You will see that in the other case we have some other operator for that. So it's not like scalar product. In scalar product, you write 4 multiplied by 3, not for numbers actually, but you write a multiplied by b or a dot b or a b. All of them are same for scalar product. But that's not the story for vector product. You need to be careful about what sign you are using. So if you are using a dot, it is a dot product which is defined like this. Magnitude of P multiplied by magnitude of Q multiplied by cosine of angle between them. And this is what it tells you. Okay. Now, in addition to this, there is one more utility of having such operator. This is an operator. Dot is an operator which operates between two vectors and gives you something, right? What it gives you is a scalar. One more thing which is very important to understand. That's why the name scalar has come. Both of them, if you see that P dot Q is giving you magnitude of P multiplied by magnitude of Q cos theta. This is not a vector, it's a scalar, magnitude. Q is also scalar, cos theta is also scalar. So ultimately what you are getting from this product is a scalar quantity. Just like work is a dot product of force, work is a dot product of force and displacement. This is a vector, this is again a vector, but this is a scalar. So what you get from the product is a scalar. That is why it is also called as scalar product. Clear? So I was telling you that in addition to this, there is one more utility of dot product. For example, not only of dot product but of cross product as well. For example, we are multiplying, let's take the example of 4 multiplied by 3 only. We are multiplying 4 with 3 and that is giving us 12, right? You can also say that scalar multiplication is also a tool from which you can decide, from which you can determine whether one number or maybe both the numbers are 0 or not. Listen to me again. I am saying that scalar multiplication is such a tool using which you can determine whether one number is 0 or both the numbers are 0 or not. Right? At least one number is 0. How? I have two numbers. I am not telling you what these two numbers are. And I am asking you, tell me whether at least one of them is 0 or not. What will you do? What will you ask me? If I was in your place, I will ask you, tell me the multiplication of those two numbers. If multiplication of both of them is 0, then obviously at least one number will be 0. Correct? So scalar multiplication, you can say it is a tool for deciding, for determining whether any one number, at least any one number is 0 or not. After multiplying you get 0 means absolutely one was 0. Maybe both of them were 0. Right? In same way, we will also define dot product and cross product. Dot product is a tool which helps you in knowing whether two vectors are perpendicular or not. How? If two vectors, irrespective of their magnitude and direction, if two vectors are perpendicular, what will be the angle between them? 90 degrees. And if the angle between them, this theta is 90, then cos 90, that will be 0. So their dot product will be 0. So you can say that dot product is such a tool using which you can tell whether two vectors are perpendicular or not. And this, what I am telling you, is not a rubbish explanation, because again I am saying there are a lot of applications if you study vectors specifically, not for mechanics or not for your engineering subjects. Specifically if you study vectors, there are many places where you need to determine whether two vectors are perpendicular or not. You need some tool to decide whether two vectors are perpendicular or not. In 3D space, you have all the I cap, j cap, z cap. Then what you can do? You can just have their dot product. If dot product is 0, they are perpendicular. So in addition to have a intuitive meaning, they are also useful as an operator in mathematical operations. This was about the dot product. It's clear why the name is scalar. It's important for you to know that their product is a scalar. Not only this case, in any case, the product that you get after the dot product is a scalar quantity. That's why the name scalar product has been given. Okay. Now let's talk something more about dot product, the Cartesian coordinates, and then we'll move to vector product. Now if you look closely in the expression of dot product, you will see that it does not have to be only q cos theta, means it does not have to be the component of q in the direction of p, but you can also consider it as p cos theta, right? Because ultimately all of them are scalar values, right? They are getting multiplied. So 4 multiplied by 3 multiplied by 0.5 is same as 4 multiplied by 0.5 multiplied by 3. So this thing can also be expressed as, if this is angle theta, then we can say that this is the component of p vector in the direction of q. So p cos theta multiplied by q. So whether it is q cos theta multiplied by p or q's component in the direction of p, or whether it is p cos theta multiplied by q or p's component in the direction of q, both of them are going to be same. So p dot q can also be written as q dot p, means p q cos theta is equal to q p cos theta. Correct? This is an important expression, and it's not easy to have this expression for the other type of product as well. So don't ignore this one, that okay, for all the multiplication we can do that. It's not like that. For the next product that we are going to see, this won't be the case, right? Okay, we'll come to that case in a moment. Before that, let's just quickly cover this. This is nothing different. In this case also we have vectors a and vectors b, just like we are having vectors p and q here. But what is the difference? Here we have written the vectors in Cartesian form. So whatever vector you have, as we know that whatever vector we have, suppose we have vector a like this, so you can write it by taking its component ax, it's the magnitude of its component in x direction, ay is the magnitude of its component in the y direction, and I cap and j cap are multiplied, which are nothing but unit vectors. They signify the direction of that vector, right? So axi is nothing but a vector in the x direction having magnitude ax. Ayj is nothing but a vector in the y direction having magnitude ay. And we have done their vector sum. It means ultimately what you're going to get, if you have ax in x direction, ay vector in y direction, and if you take their resultant, what you will get? You will get this resultant vector a. So this is one more way of representing them using rectangular coordinate, using Cartesian coordinates. So similar way we have written vector b as well. Okay, and when you do their dot product, what ultimately you get can be expressed like this: ax bx plus ay by. So simply you have to multiply this number with this number. It will be a number like 2i plus 3j, right? A number like 4i plus 2j. So a number will be there. That number you have to multiply. X coordinates number ax bx you need to multiply, ay by you need to multiply, and add them up. Upon doing that, you will get their dot product. Alright, now let's move to the cross or vector product. Now let's talk about the cross product. So these names, dot product and cross product, they actually signify the operator which is used to represent them. For example, dot was represented by a dot, and cross is represented by a cross sign. So if we are having cross product, means two vectors will be denoted by a cross sign between them. So dot and cross don't represent the same thing, just like they represent the same thing in scalar multiplication or scalar product. Alright, so why do we need another type of vector, product for two vectors? Look, it's not necessary that two vectors when multiplied together will always result into a scalar quantity. Do you think so? Work is a case, obviously, but there are cases when you are multiplying two vectors and you are getting another vector, third vector. Their multiplication is not giving you a scalar value, right? For example, torque or moment of a force. You multiply force with the displacement. Force is a vector, displacement is a vector, and what you get as a result? Torque, right? Or moment of a force, which are vectors, which are having a direction and magnitude as well. So how do you represent those multiplications? Obviously, you're going to use dot product because it gives a scalar value as the resultant. So for those cases, we are having one more type of product which is called as vector product, as I have written here, or cross product as represented by the shape of the operator. I told you that before we are defining these products, it's very important to have the objective in your mind. Just like objective was clear in scalar product, in a similar way for product of vectors, objective should be clear, and the objective should have some usage as well. What are the usage in this case? I have given you the example, torque or moment of a force, right? Now if you look at the expanded expression of cross product, how you actually cross product, take cross product of two vectors, then you take magnitude of one and the other, you multiply them. Obviously these are the magnitude scalar values. You multiply them with the sign of angle between them. But you will say that all of these three are scalar values, so how come it is giving a vector as a result? That is decided by this value n cap. Just like few minutes back I told you that what was AXI representing? This was the magnitude in the direction of I cap, which is x direction, right? In a similar way, P cross Q is giving you a vector which is having a magnitude of P, Q, sine theta, and n cap is representing the direction. And n cap specifically represents a direction, just like I cap represents x direction, and j cap y, and z cap or z cap z direction. In a similar way, n cap represents the normal direction. Means this vector, which is formed by cross product of two vectors, which is a third vector, a new vector, is having the direction normal to the plane of P and Q. Now what do I mean by saying that? Let me explain you using this diagram. We are having a vector P and a vector Q. Both of them are lying in which plane? In this plane, in the plane of whiteboard, right? In fact, any vector you choose, any two vectors, if you have one vector like this, other vector anywhere you put, it doesn't have to be in the vertical or in the horizontal plane, anywhere you put, you can pass one plane through both of these vectors, right? That plane can be horizontal, vertical, or at any angle. As long as you have two vectors, it is possible, correct? So whatever will be the plane passing through two vectors, so in this case your mobile or your laptop screen is that plane on which P and Q are drawn, right? So n cap represents the normal direction of that plane. Means n cap will be representing the direction perpendicular to this whiteboard or perpendicular to your screen of your mobile or laptop screen. Alright, so that is another vector. You see, two vectors we have multiplied, they are giving third vector which is perpendicular to both of them. And it is useful, it is used when we are calculating moment of any force, or that we call as torque, right? So this vector signifies something, it has use, and just like I told you that whether two vectors are perpendicular or not was decided by their dot product, same you can do here also. When sine theta, this will be 0, then cross product will be 0. So you can say that when two vectors are in the same direction, then their cross product is 0. So cross product is again a tool to determine whether two vectors are in the same direction or not, or maybe in the opposite direction. Sine 180 is also 0, right? So this is what we have now. Now what exactly Q sine theta represents? We can see that if you want to represent this angle as theta, then this is Q cos theta, and this line here is representing Q sine theta, right? So there is one more, although the thing that I am telling you right now is not that much useful for mechanics as such, but you can say that cross product, the magnitude of cross product also represent the area of parallelogram. This is parallelogram, let me write it in full. Parallelogram formed by vector P and vector Q, because Q sine theta, this, when you multiply this with this length, with the length of P, you get the area of parallelogram which will be formed, right? If you form a parallelogram using them, then Q sine theta and P will be, their product will tell you the area. This question is asked but not in GATE or any other examinations, because this is too much into the vector thing which is not in our syllabus. Okay, so this you don't need to write. Okay, now how do you decide the direction of n cap, whether it is coming out of the screen or going into the screen? Because both of the directions are possible, right? The vector can be coming, the vector from their cross product, it can be coming out of the screen like this, right? like this. The point will be headed towards you, or it can go inside the screen. Both of the possibilities are there. Just like P can be in this direction, plus X or minus X. Similar thing is possible for n cap as well, right? That is decided by right hand thumb rule. What you need to do, you need to use your right hand and align it in the direction of P, like this. Okay, don't do it like this, such that only one finger you can see in that manner. Since it is P cross Q, you need to align your hand in the direction of first vector which is coming. First vector is P, so in the direction of P I have placed it. And now I will curl it, I will close it, I will make it a fist by curling it along the direction of Q. So P is here. If I move it along the direction of Q, the direction of thumb will represent the direction of the resultant cross product vector. You can see that if I do it like this and I curl my fingers like this, the direction of thumb is representing that arrow is coming out of the screen, right? That is the direction of cross product. That's how we will define the direction of moment of force or torque. All right, there's a representation. To do that. We have already covered the representation in class 11, but let's do that again. When a vector is coming out of the screen, then it is denoted by a dot like this, and when it is going into the screen, it is denoted by a cross like this. To remember this, you can think of an arrow. If an arrow is coming towards you, if someone shoots an arrow towards you, you can imagine, I hope you never get shot by an arrow, but if an arrow is coming towards you, a point will be visible to you, right? The first point that will be visible to you will be the pin, that the cone of that arrow. So it is represented by a dot. But when you shoot an arrow, what you are able to see? If the arrow is like this, so what you will be able to see? From the back, this part will be visible, which is a cross. It is just a way to remember it. It's not, I'm not sure how this was named. You don't have to know that. But this is how you can remember that if a vector is coming at you, you are looking at the screen, you are looking at the plane, and if a vector is coming at you, it will be represented by a dot. And if a vector is going into the screen, that will be represented by a cross. It's not a concept, it's a way to remember it. Okay. So in this case of P cross Q, where do you think the direction of this vector will be? Just align your hand along P, curl it, the thumb will tell you. Thumb is going out of the screen. So this is the direction. If you are having Q cross P, so what will be happening? The magnitude is not going to change. Magnitude will remain same. Sin theta is same, P and Q same, their magnitude will be same. But the direction of this n cap will get changed. How? If you do Q cross P, you will align your right hand along Q, and then you will curl it with P. So where is the thumb going? Inside the board. So it will be represented by a cross. It was represented by a dot, right? So this is how the cross product works. Now recall that in case of dot product, I told you that P dot Q is equal to Q dot P, because all of them were scalars. Do you think it is the same case here? No. It is a vector, and vector don't work only from magnitude, they also include direction. Although the magnitude of both of them are same, right? PQ sin theta and QP sin theta, magnitude is same. But this thing here is different. It is going into the board, it's coming out of the board, and this one is going into the board. So basically magnitude is same, but direction is totally opposite, 180 degree. So what we can write here is that cross product of P and Q is not equal to cross product of Q and P. Rather, it is negative of that, right? Because magnitude is same, but only direction is opposite. So to represent opposite direction, we use a negative sign in case of vector. So this also you can remember. All right. So if the vectors P and Q are represented in such a form which I have already discussed. So P is written as Pxi, Pyj, Pzk, and Q, Qxi, Qyj, and Qzk, and their cross product is represented like this. It's a determinant. I, j, k, then the coefficient of I, j and k in both the vectors are written. This value is going to give you the value of cross product of P and Q. How do you calculate this determinant? This multiplied by Py multiplied by Qz minus Pz multiplied by Qy. So this you multiply. These are the basics of mathematics. Then Pz multiplied by Qy, and you multiply that with I cap. Then for this one a minus sign will be coming. Then Px Qz minus Pz Qx, and then J cap. And then for third one again plus sign will be coming, and then Px Qy minus Py Qx. Py Qx J cap. Alright, for those of you who are not aware of what is determinant and why we are doing this, then you need to cover engineering mathematics first. Alright, so this was about the product of two vectors, and trust me, we have covered it in enough detail which is more than required for any of your engineering subjects.